morning, trig fans. How we doing on this fine, sunny Tuesday morning? It's sunny outside. Still a little chilly out there, but the weatherman says it's going to warm up, and that's a good thing. Hope everything's going well with you and your family. Please do keep up with the material that we're going through here. The end is near. We have this week and we have next week, and we'll be done with all of our material that we have to cover. Today what we're going to do is we're going to go over one of the homework problems that you had for today with respect to adding the vectors and determining an angle. Was problem, I think, number 3 on your homework sheet on the back side. Once again, if you have any questions at all, feel free to make a comment to me and I'll respond back to you, or we'll go through a problem here. I just thought it'd be good to go through a problem today. What I have here is calculate the magnitude of a plus 2x. A plus 2x. X is a value of 3, a has a length of 8, and then we have sort of a cat dog going on here. We're connected at the tails. We have a 100-degree angle that forms these two vectors, Victor. We want to be able to find the resultant vector. When we're adding this, when I ask you to find this, I'm looking for the magnitude of the resultant vector, Victor. Because obviously we just can't take a, which is a plus 2 times x, which is 2 times 3, 6, and get a value of 14. We're not going to get that. We have to go with respect to it at an angle. The first thing we want to be able to do is we want to be able to draw a plus x. A plus x. Well, or a plus 2x. So what I have to be able to do is I'm going to travel a first, which means I'm starting here and I'm traveling the distance of a, and I'm ending here. This is my terminal position. Okay, wherever I stop my first vector, I'm going to start my second vector, Victor. So I'm going to move x all the way down to here. Okay? Once again, this is now the initial position for x. This is the initial position for x, and this is the terminal position up here. Now, the angle that is formed between these two is if I would just continue to move this line across. This angle that is formed right there is 100 degrees. If I slide this over, the 100 degrees just continues to go with it. So if I slide it over more, the 100 degrees will just continue to go with it. Well, if I go to the very end, my 100 degrees is going to be right there. Which means, what does this angle have to be that's formed between this vector addition? That's correct, 80 degrees. Now what we want to find here is we want to calculate this resultant vector. Victor? We want to find the magnitude of this resultant vector. Well, a we have is a value of 8. And I said that, well, that's just x. If I wanted to, I could draw in 2x. I could clone this and take it up here, which means that would be our resultant vector then, Victor. But you do not have to draw it to scale. I just could have said this is x, but then said, well, the length of what I want here is 2x, so this length is a value of 6. Because I'm looking for 2 of the x's. 1 of the x's is a value of 3. 2 of the x's has to be a value of 6. So this is a drawing of a plus 2x, where we have 80 degrees here. We don't know what this angle is. We know we have this length is 8 and this length is 6. Well, what we have created to find VR is we've created a law of cosines equations, which we just did last week. So I'm going to write my law of cosines equation out. VR squared equals 8 squared plus 6 squared minus 2 times 8 times 6 cosine of my 80 degrees. And once again, you can click-clack it straight into your calculator. We could go straight into our calculator with this value. We don't have to do pieces parts. We could just type in 8 squared plus 6 squared minus 2 times 8 times 6 cosine of 80 degrees. And this gives me VR squared, 83.32 or 33. And then I can square root, second square root, my answer, just pull my answer down, and I get 9.12. So this VR is 9.12. Now the other thing I ask you to find is I ask you to find the angle formed by the resultant vector and angle A, or vector A. We could use one of two things. I could use law of sines here, or I could use law of cosines. Now, if you know your triangle properties, this is my biggest side. This has to be my biggest angle. So this here is 80 degrees. This has no chance of being an obtuse angle then. But if I needed to, I could write my law of cosines equation. 6 squared is equal to 8 squared plus 9.12 squared minus 2 times 8 times 9.12 cosine of this angle alpha. I can subtract my 8 squared and my 9.12 squared. Find my value here. So I have 36 minus 64 minus my answer squared. See, I can just pull that down there. I get a negative 11.32. And I can divide this by negative 2 times 8 times 9.12. And do second cosine of my answer, and I get 40.27 degrees. So my alpha value is 40.27 degrees. If I wanted to use my law of sines, I could have done that also. The sine of 80 over 9.12 is equal to the sine of alpha over 6. So the sine of alpha is equal to 6 sine of 80 divided by 9.12. The problem you have with this though is you have to watch when this alpha, you're trying to find this alpha value and this side is the biggest side, you have to make it, you're going to have problems. You can run into problems then using the law of sines. I would suggest using your law of cosines. So we have 6 sine of 80 divided by 9.12. 6 sine of 80 divided by 9.12, and I can take my sine of this and I get 40.38. Not going to be exact, but it's going to be close. And this is the problem that you had. Once again, this is problem number 3 on the back side when you're adding with values. Today what we're going to deal with is we're going to deal with one last type of problem. And the review sheet or the worksheet that I give you today will have some problems like we had on the front, plus a couple of the bearing problems here. That's what you'll be dealing with today. Up until now, we have dealt with an theta value, which is an east reference. We have dealt with angles where I'm rotating from, if I would put directions to this, rotating this direction. That is what I call theta and an east reference. And that's what we've been dealing with up to now. It's what your calculator is set up to deal with. there's a second type of measurements for degree measures, and that's in bearing. Bearing is a north reference for the initial side of the angle. Clockwise is a positive rotation. Clockwise is a positive rotation. Now, where bearing is used a lot is in aeronautical, or the aircrafts and also the ships that go out into the oceans and go out boating. The reason why is this is based on your compass. And the compass always has a north reference. Okay, the compass always goes towards the north. So when you're dealing with a compass, you deal with the idea of bearing. And when you're in the air in an airplane, you don't have no frame of reference in regards to a direction that you're going. When you're on a ship out in the middle of the ocean, you have no bearing on with the direction that you're going. You need to have a compass there, which is a north reference that will tell you which direction you need to be going. Once again, you have a north reference here. And you're going to be rotating clockwise. And this is bearing. Now, there is no negative bearing. Everything is a positive bearing, and it stays between 0 and 360 degrees. Let's take a look at a problem. A plane flies on the bearing for 70 degrees for a distance of 100 kilometers, then turns and travels on the bearing of 140 degrees for 200 kilometers. What's the plane's distance and direction from its initial position? Well, where we're going to put the initial position at is right here at the origin. The first direction they tell us is we are going to be going on a bearing of 70 degrees for a distance of 100 kilometers. So I'm going to rotate this 70 degrees. This is a rotation of 70 degrees. And we're going to travel 100 kilometers. So that's one side of our triangle that we're going to formulate. So I'm rotating 70 degrees and I go 100 kilometers. Whenever I stop here, here's my terminal position. I start a new direction and a new bearing. Okay, I start a new direction and a new distance here, a second vector. Victor. What I suggest that you do, this is my suggestion, is at the terminal position, draw in another little axis. Draw in another little axis because this is going to make it a lot easier for you. Because I'm going to draw in a second vector. Victor. Here's my north reference. Once again, here's my north reference. Here's my north reference. I'm going to rotate this 140 degrees. So I'm going to rotate, whoopsie. This is 90 degrees. This is 180 degrees. So I'm going to go 140 degrees. And it does not have to be exact. And I'm going to travel 200 kilometers. What we want to find is we want to find this resultant vector. We want to find this resultant vector, Victor. What we have just created is we just created a triangle. And once again, what we're going to be utilizing is the law of sines and the law of cosines here to be able to solve for VR. Because I know two sides of this triangle already, I need to find the third side. Well, if I know two sides, I need to know this angle in between here. And that's the puzzle that you have to figure out. you have to figure out this puzzle of what is the measure of this angle. We have the two sides. I need to now know what my angle is. Well, I need to know the entire angle, and you may not be able to find the entire angle at one fell swoop. But you could do it in pieces parts. If I rotated from here to here, that was 140 degrees. What would be the measure of this angle right there? Well, if I go from here to here, that was 140 degrees from here to here. What's that lead to get down to here? That's correct, 40 degrees. That is 40 degrees. So that's part of my angle. The other part of the angle, I need to find this measure. Well, if I go to find this measure, I use this angle to find this part. I need to use this angle somehow to find this angle. Well, if we take a look, we have two vertical lines that are parallel. And we have a transversal. If we take a look, this angle is 70 degrees. This angle here also has to be 70 degrees. Well, what we use here is a geometry idea. If you have two parallel lines cut by a transversal, these are called alternate interior angles. They have to be congruent. If they're congruent, they're going to have equal measures. So if this is 70 degrees, this is 70 degrees. And this is sort of like the little puzzle to try to figure out when you make your diagram. Well, if this is 70 and this is 40, we have a total angle here of 110 degrees. So if this total angle is 110 degrees, I know these two sides, I now can find VR by using law of cosines. VR squared is equal to 100 squared plus 200 squared minus 2 times 100 times 200 cosine of 110. So going to my calculator, we have 100 squared plus 200 squared minus 2 times 100 times 200 cosine of 110 degrees. And we get 63,680, and then we have to square root my answer. We get 252.35 kilometers. So if I travel here, then travel here, and sometimes you have to go different patterns to be able to do traveling. You might be going around a thunderstorm, you might be getting around weather issues or high traffic patterns. You just go a little bit differently than what you would normally go in a straight line. So our resultant vector is 252.35. Now, that's only one part of my solution. To get a true vector, I need to know magnitude, which is this, and also the direction. If we take a look at our triangle, you will always have an angle here at the original origin. I'm going to call that once again alpha. This is the angle we want to find. And if we take a look in our triangle, this is 110 degrees. I already have an obtuse angle there, so this one can't be obtuse. So I could use my law of sines. Sine of alpha over 200 is equal to the sine of 110 over what I just found, 252.35. Cross multiplying, the sine of alpha is 200, sine of 110 over 252.35. So going back to my calculator, once again, I'll show you a trick here. We have 200 sine of 110 divided by, well, my answer is still there from what I had, so I can just divide by my answer. And that's the sine of my alpha, or the sine of my angle. So we have the sine of alpha is 0.7447. But I don't really need that. I can just do inverse sine of my answer, and once again I can just pull that down, and I get 48.14 degrees. So this angle here is 48.14. Now we started out in bearing as my direction. My solution also needs to be in bearing, which means I need to know how much of rotation do I have from here down to my resultant vector. Victor? Well, if this is 70 degrees and this angle here is 48.14, what do we have to do to those? That's correct, we have to add them. So we have 118.14 degrees is our bearing. And the symbol we use for bearing is a Greek letter B. Once again, if I went too fast through this, once again, hopefully you remember just to hit pause and slow me down a little bit. But this is the other type of problem that we're going to go through. So what we have is we have drawing of vectors, resultant vectors, by just graphical things. Then we have problems like this, where I give you some numbers. And the last type of problem that we're going to see is we're going to see bearing problems. So we have 3 different types of problems that we have to deal with here. Okay, I will post a solution, or I post a worksheet and a solutions to these types of problems. Once again, it gives us additional practice. I'm looking for, unless you guys say something different, I'm looking for a review day tomorrow, and then on Thursday and Friday have your evaluation over vectors, Victor. So unless you talk to me or say something to me to slow me down, that's my plan. What I would suggest is if you have questions about any of the problems, and what I may do tomorrow is I may come in and just go through some additional problems from your worksheets, just to go through them again. That will be tomorrow before I post a review sheet, and that will give us a little bit more time in regards to going over types of problems and get a little bit more explanation. But once again, looking for Thursday and Friday being the evaluation over vectors. If you have questions, please comment me and ask. If you have a particular problem you'd like me to do, please comment me, tell me what you'd like me to do. I take requests. Other than that, I have nothing else for you today. Once again, work on the problems we have. Enjoy some of the sunshine. Maybe sit in the window where the sun shines at. It would be nice and warm for you. Greenhouse effect. It'll be nice and warm with the sun that's out there today. Other than that, I have nothing else for you. I miss you guys, and we are close to being done. So let's keep it going here. Other than that, I have nothing else for you. Adios. See y'all.